So since 2013, I've worked on the stormwater management program with the Department of Transportation Highways, Oahu District, as a consultant. And one of the programs that I manage is the post-construction stormwater management and new development and redevelopment program. And so one of the things we're doing this year, the main point of this conference is the construction site runoff control program. And the swamp program as a whole has all these other elements as well. And today we're just going to talk a little bit about how the post-construction program relates to the construction site runoff control, because in a sense, all these programs have some overlap in relation to each other. So first of all, what is a post-construction or permanent best management practices? Those two terms are kind of used interchangeably. Post-construction is the name of the program. These best management practices are also referred to as permanent. A post-construction BMP is a BMP that will remain in place following construction to minimize discharge of pollutants from activities on site. So that differs from a construction BMP that you're only installing to protect the site during construction activities. These are actually meant to stay there long-term, somewhat permanently, to provide stormwater treatment after the project is complete. A particular type of post-construction BMP that we try to prioritize is low-impact development, and that is attempting to mimic pre-development hydrology. So rather than treating stormwater like a nuisance and just getting it out of the storm drain as quickly as possible, we want to actually create grass swales, storage ponds, and other types of scenarios where the stormwater can actually remain on site and infiltrate and recharge groundwater, provide water for plants, stuff like that. And then through that low impact development, through that slower process, the excess nutrients and pollutants are also taken out of the stormwater before it discharges. So why do we even put in post-construction BMPs? As part of the post-construction program, there's a unified criteria that says any project that disturbs more than an acre is required to be reviewed for permanent stormwater controls. So that's part of the permit requirement. That's part of DOT Highway's permanent BMP manual. And then also smaller projects that have high potential for pollution, like gasoline station, car washes, auto repair shops, restaurants, are also required to be considered for permanent best management practices. This is the cover of DOT Highway's permanent BMP manual, and this is your resource for what triggers permanent BMPs, the design criteria you're going to use for permanent BMPs. It's kind of your first go-to guide for figuring out if your project would require permanent BMPs. And then, in addition to the unified criteria, which is triggered by larger projects over an acre, there are other overlap in other programs. DOT Highways has an action plan for retrofitting BMP structures, which is just going into the older system and finding opportunities and locations to install stormwater treatment where it wasn't previously installed. We have total maximum daily load monitoring plans, so TMDLs and waste load allocation reduction. DOH, working with EPA, sets standards for nutrient reduction, and wherever DOT's highways go through watersheds that require nutrient reduction, they're required to have a certain reduction in load based on the area of land. So in those areas, we put in permanent BMPs to take out nutrients to meet those waste load reductions. We have an erosion control program where we're just basically trying to fix any area of erosion on the side of the highway within right-of-way that has the potential to discharge and erode water into the storm system. Action plan to address erosional outfalls. DOT has thousands of outfalls. Over the years, they do tend to erode, and it's sort of the last point that we can prevent erosion and pollutants from going into the ocean. And then the trash reduction plan. As of 2016, DOT Highways is implementing their trash reduction plan, so a lot of our permanent BMPs are geared toward reducing the trash loads. And then once all these permanent BMPs are complete, they're tracked and inspected and maintained ongoing under our post-construction program. So as contractors or designers or inspectors or DOT staff, one of the critical things for you to think of when you're reviewing a post-construction or permanent BMP project is that, you know, as opposed to a construction BMP that might only be in for a couple months, a couple days, these are meant to go in the ground and last for, you know, years. We say permanent, but nothing's really permanent. But so proper installation is critical for optimal long-term function. And then another thing to consider, structural BMPs, like treatment devices, stormwater treatment devices, typically include a 9 to 12 month maintenance period. So as contractors, you're going to be required to understand how to maintain that device and maintain it for whatever period the specification requires. And that's really valuable information for us because we use that data to plan the long-term ongoing maintenance of these devices. And then vegetative permanent BMP projects that require landscaping, stuff like that, those typically include a plant establishment period as well as a maintenance period to make sure that the plants are actually going to function properly. So just to give you a few ideas of, let me see my time, of the types of projects that are typical to DOT highways. Being a highway system, we're a little bit limited. We can't do a lot of the LID techniques that could be done by maybe city and county. We don't have a lot of parking lots or large square plots of land. Mostly we are dealing with narrow right-of-ways. So these aren't the only types of BMPs we install, but these are some of them that are more typical. So first of all, just permanent erosion repair. So these sites, we have a few different techniques, and the actual technique we use tends to be site-specific given the conditions there. But like this one, for example, we put a semi-permanent erosion control matting down, and then we trying to establish a native grass population. Most of the right-of-ways are pretty much overtaken by invasives at this point, and so as we reestablish vegetation in the eroded areas, we're really trying to reestablish native populations, and that's the reason for that plant establishment and maintenance period. Let's see here. The other types, sometimes we have areas that are underneath the freeway overpass where we can't establish vegetation. So in these cases, we end up putting a hardened surface or a combination. Here you can see once we got out from underneath the overpass, we actually put fabric and plantings in. But this is called a grouted riprap. So basically, it's applying grout to the surface and then layers of riprap and cementing it all in, kind of creating like a permanent wall so that the soil will stop eroding off into the storm system. Grass swales and bioswales. So these are an LID technique that we're having some success with because they can be installed in a linear fashion. And a grass swale is basically just creating a depression in the ground and with a grass surface that the water has to flow through before it gets to the storm drain system. So it allows some of the pollutants and nutrients to settle out before getting to the storm system. This one in particular, you can see this is the edge of this used to be a concrete channel. And the whole thing used to just be a concrete channel, but we actually tore out all the concrete on the bottom and the side. We left this little piece to stabilize this steep slope here. And now this is actually a bioswale that has some engineered soils and an underdrain system. So that as much as possible, we like to promote infiltration, but whatever water can't infiltrate on site, at least goes through the engineered soils before it gets to the underdrain system and then discharges. And here you can see a cross section of this same type of system. So we've got this aggregate storage layer where it's more of a coarse rock that is an area for water to just pond, settle out, infiltrate depending on the conditions of the site. It's pretty common to put an underdrain in there so that it doesn't end up overflowing. You have the engineered soil layer. This is usually site-specific to the type of pollutants or nutrients that you're trying to remove at any given site. And then Surface plantings, again, this is another opportunity where we try to establish native plantings and native grasses. And so this, as contractors, it's really important to us that you follow the specifications and put in the engineered soils correctly. Here's an example on the H3 freeway, just right down the street here. In the median, headed toward Kaneohe, DOT Highways took out a bunch of these. Previously, the road drainage just went into these concrete asphalt swales, and then they went straight into storm systems. So they busted out the concrete swales and then dug these bioswale trenches and put in this aggregate storage layer. And so this is a critical time during construction. Sometimes while you're doing this process, maybe you get a rain event. We've had this happen where this is where your construction BMPs are really important to protect the permanent BMP, because a bunch of sediment, sand, silt eroded into some of these aggregate storage layers, and then all of a sudden we have a system that's not going to function as it was designed. So a lot of this stuff had to be pulled back out and reconstructed. And then after it's had the engineered soils and the top layer, this one just has native grass hydroseed mixture sprayed on top. And now you can see the final product is, instead of just going in a concrete swale straight out the system, we're going to get a lot of infiltration on the really high flow events, more surface flow and surface treatment. Another thing that DOT Highways deals with a lot, they have a lot of elevated freeway systems, viaducts, and connected to these viaducts, there's a lot of downspout filters. So when you're driving on the elevated freeway, you see a storm catch basin. That has to go somewhere. It doesn't just drop to the ground below. It typically goes through the concrete columns or attached to the concrete columns through a pipe. And then those pipes sometimes just discharge straight onto the ground, and then to maybe an underground storm system or a nearby outfall. So in a lot of these areas, we're installing these concrete boxes. So basically we just have the pipe, instead of just discharging onto the ground, goes into a concrete box and then has this screened outlet. And once the dirt gets to a certain height on the screen outlet, that's got to be cleaned out. Tool that we're using for our trash reduction plan, these are the automatic retractable screen guards. I'm not sure if you have seen these. I know they use them a lot in California. There's a few different models. We've installed quite a few of these on the windward side where we get a little more rain, kind of as a pilot project to see how much trash they collect. But an advantage to these, once they're installed and they're basically blocking trash and other debris from getting in the sediment basin, the maintenance is actually the street sweeper. So we're already street sweeping on these routes. So this prevents the garbage and trash from going inside the catch basin before the street sweeper gets there. When the street sweeper hits this, it actually stays solid. It does have a mechanism inside where on really high flow events, it'll trigger and open the hatch so that we don't have flooding. And this is also why we leave a little bit of a gap at the top here, so we don't cause flooding or ponding on the road. So you kind of got to balance those things. And then we also have some issues with just getting a lot of organic debris built up in front. And so it's kind of something to consider when you're designing where you're going to put these. Is there a tree right above that's going to cause a lot of organic litter? Once this gets clogged up with organic debris, then the opening mechanism stops working, and it can become a problem. But again, this is a device that we're going to ask you as contractors to maintain for 9 to 12 months, and that way we can collect this data and figure out where we might need to sweep more often to keep this kind of thing from occurring. So this is another fairly simple device. It's basically just a basket that goes inside of it can go in a graded inlet, a curb inlet, and usually want to size it specifically for the flow that catch basin receives. There's a couple different styles that we've installed. This one's a metal basket, it's round. It does have, both of them have this hydrocarbon boom that helps take greases and other toxins and stuff off the roadway. And then it just has different layers of mesh that are finer at the bottom and get more coarse toward the top. So if this thing gets full before it's been maintained, it can overflow and not cause flooding on the highway. These are pretty simple device to maintain because they're typically only 1 to 2 feet deep. You can usually use just a shovel, or even I've seen contractors use a shop vac. Some of the other BMPs we'll show you in a minute actually require a vac truck. These can be cleaned with a vac truck, but sometimes it's overkill. This is just looking down into a catch basin that has one of these baskets installed. And then we're getting into more of the large-scale stormwater treatment devices. This is hydrodynamic separators. This is a specific type of hydrodynamic separator called a continuous deflection separation unit. We call them CDS units. So these are a lot more labor-intensive to install. They're usually pretty deep. We have some over 20 feet deep. They have a pretty complex system where as the water flows in, the floatables are trapped in the top. It creates a swirling motion. This is the hydrodynamic portion, and it has this special screen that continuously deflects all the sediments toward the middle like a whirlpool, and then they settle out into this chamber in the bottom, and then all the clean water is allowed to flow out. So something we want contractors to be aware of is you're going to be maintaining this device too, so it's important for you to understand how this works. Typically our specs include a maintenance manual, and you need to know how deep the device is. You need to know which part to measure. One issue we've had is measuring down and hitting this little shelf right here and thinking that there's sediment to this level. But what we really want, you got to get all the way down the middle into this sump area and measure that sediment. So just something to look out for. Another type of device that's typically installed at the end of a long run of storm drains. This is where we can get more treatment in one location of a larger volume of water. Nutrient separating baffle boxes and water polishers. We have a probably 6 or 7 of these in the ground right now, in a range of sizes. We have some pretty large ones over here in Kaneohe in the windward side where we get a lot of rain. But the reason they call it nutrient separating is it tries to keep all the different types of nutrients and debris separated. So in a typical system, if you get a bunch of leaves and organics mixed in with the sediments, that over time the organics leach nutrients into the water in between cleanings. So this device actually traps all the floatables, trash, leaves, and other organic debris in this cage in the top, and then there are baffles installed between each of these deflectors installed between the baffles that promote settlement, and each chamber promotes finer and finer sediment. By the time you get to the last chamber, you're just really dealing with fines and sludges, and then it's got this oil boom system to get any greases, hydrocarbons out of the system. The water polisher is installed in locations where we might need more dissolved nutrients or finer particle removal, and everything that flows through, these can be installed in sequence or separately. Everything that passes out of the end of these devices ends up having to go through this upflow filter, and this media can be changed out and targeted toward your pollutant that you're trying to remove. Another good thing about these devices is they work well in areas where you don't have a lot of vertical fall. Most of the devices you want to have a good vertical drop for water to flow through the filter system, whatever that might be. These devices work with almost 0 grade drop, so that comes in handy in a lot of locations. Here's a couple of photos of one of these being constructed. This one also just right down the street. This was the existing, I think it was a 48-inch, maybe a 36-inch, but basically just cutting out the hole in the old pipe. You can see dropping the box in here. This collects a pretty large drainage area up above, and it used to just flow right through this pipe and straight into the stream channel here. Now it has to flow through this baffle box, gets cleaned out before it goes to the outfall. But the excavation was pretty extreme for this one. They did have some issues with groundwater in the bottom, so stuff you want to anticipate as a contractor. And then I also just wanted to point out that sometimes you guys as contractors are really helpful to us because you see what's actually happening on the ground. When we're designing stuff in the office, it's kind of theoretical, and when you start digging around, when you start putting these things in, you kind of see what's going on. So this is kind of funny, but this is out in Waianae, this baffle box water polisher that we put out in the base yard, and contractor notified us and said, "What do you want me to do about the cats?" So we're like, "What do you mean the cats?" So he said, "There's cats living in the box." So there's a pretty significant feral cat population on Oahu. It wasn't something we anticipated in design, was having to deal with cats, but it was a nice little nook for them to crawl down into. Definitely not something we want, as this is a nutrient removal device. So it enabled us to work out a solution, which was to get them a dog. And no, I'm just kidding. But what we actually ended up doing was just putting a screen on the outlet, and that kept the cats out. But those are there's been other examples too where the contractor can provide really valuable insight when they're out there actually doing the job, and we appreciate that feedback. So water polisher inspection and maintenance. This is again similar to a baffle box. This is the water polisher though that actually has the filter. So again, remember you're going to be maintaining this for 12 months. It's important to us that you collect valuable data, accurate data, so that we can use that to plan our long-term maintenance of these devices. This is as the water flows into the system, this is that basket that floats on top and collects leaves and trash and other floating litter. And then this one is going to require a vac truck. We have had issues where someone shows up to maintain one of these devices. They don't even have a vac truck. They have like a scoop net. No confined space entry guys available. So basically we can't actually get the device cleaned. So you're going to need confined, technically you can clean these without confined space entry. You can clean them from the surface, but it seems like on the deeper ones, most of the contractors that clean these do use confined space entry, and it's easier to just get down in the box to get those deeper chambers. This one, another key is this filter. We've had several instances where the cleaning's going well, and then we find out toward the end that the contractor didn't bring any filters to replace. So then they have to come back, drain the water down again to get to the filters. So this is all stuff that we want you to be prepared for and would be in the project specifications. And this is just a sample, but you'll be provided with a form that we would like you to provide the data on as far as the weight and volume of debris, the different types of debris, and you can log when you change filters and all that kind of stuff on here as well.